Raman. See, we said about Raman, the advantage of Raman is you can get discretely tunable lasers from now add this one, from UV to IR. UV to IR.
Smiling.
Not smiling, smelling.
Smelling, yes, yes.
If you smile, everybody will like you. You smell. It is a smell. Okay. You can get from UV to IR. I gave you one example. If you start with 355, you get one in UV. And you will get one in IR. Like that you can play around.
Raman is belong to the molecules material or liquid material, no solid material?
Yes, that's a good question. So, now, there is, yes, Raman laser is discretely tunable. What is continuously tunable laser? Okay, you must answer this question. Now, let us go to what he is asking. Raman laser is good with liquid. What about solid? What about gas? In fact, Raman laser is really very good with gas sometimes. Liquid, I can tell you, most of the organic liquids. Most of the organic liquids, most of them will produce laser, Raman laser. Now look at it. Take this question. Most of organic liquids will produce Raman laser. Same question. Why I say most? First thing. Why I say organic? Then look at it. Most of inorganic lasers, inorganic liquids will not produce lasers. It will not produce you see? Example, organic liquid, as I told you, if you have patience, I can do experiment with you for one semester, show variety of laser from all of them. But you know NaCl?
NaCl, ions.
Huh?
What is it? Ions.
NaCl?
Salt.
Yes. If you take NaCl is a salt, put it in water, it becomes sodium chloride ion. Suppose I produce a laser, it will be big news. I cannot produce a Raman laser from sodium chloride solution. Understand? On the other hand, I can take acetone, I can take chloroform, I can take carbon tetrachloride. You know how many organic liquids are there? There are few million. Okay. All of them will produce laser, Raman laser. Understand? At least most of them, 99% of them will produce laser. You must tell me why. Secondly, I come to gas. Now, gas, I can get laser from CO2, CO, carbon monoxide, N2, oxygen, all gases. Usually what is done, look at it, I have a tube like this, put the gas CO2, seal it, look at it, I pump using 532, then I put a grating, I put usually a reflection grating, then I will have so many colors coming out. I will give you a thesis of one of the students who did with this. You see the solid round? He put the gas, where is the cylinder, up to 6 atmospheric pressure. That's a cylinder. The gas cylinder is 6 atmospheric pressure. He took carbon dioxide from somewhere in this, and then we worked together and he was able to get laser in so many wavelengths. Why should he pressurize? Why should I give more pressure? First question. Second question.
For CO2, more pressure.
CO2, CO, always you
For gases.
all gases, 4 atmosphere, 5 atmosphere, everything. Why you need high pressure? That's a good question. Secondly, keep this question, you must answer for all this one. This I did with 532. If this laser is working, 358, okay, put this, you have hydrogen, H2 gas, I think it is 6 atmosphere. Then look at it, they were able to get so many lasers, and it is very, very efficient. Conversion efficiency is very good. I can, when at the end of this, remind me, I will show you a very beautiful article which came in, which hit the headline, because you can get so many lasers starting from one laser. Even now, with the 355 which we have, I can show you can get so many lasers. Okay.
I think, Doctor, we don't need crystal.
Yes, we don't need a crystal. We don't need a crystal. Now, what's the advantage between, now the question comes. So this is very good, liquid also is very good, but I don't do with the solid. In principle, I can do with the solid also, but in practice, it is not so good, because most of the solids, the question is this: Raman laser is best with liquid, next best with the gas, third best with the solid. Why? Most of the solids are inorganic. For example, if you take NaCl, you have crystals like this. You have Na, you have Cl, Na like this. Okay? This is no good for laser, for Raman laser. In fact, this is no good for any kind of laser. You cannot produce laser in any way from NaCl. That means all inorganic solids are not good laser material. As a rule, you can put them in a bag and throw. But there are certain crystals, organic crystals, some some crystals like, wait a minute, some crystals like nickel or some crystals, they respond to Raman effect. But it's very difficult to get a optically pure, good quality crystals. Optically pure, good quality crystals are difficult to get, and it is expensive. Since it is expensive, I don't have to use Raman laser. I can use as a parametric oscillator. See, the advantage of Raman laser is you can get a good quality laser without phase matching condition. Put it in a liquid, pump it, you will get the laser. No botheration about tuning, adjust the wave. Same thing in liquid, because there is no need for phase matching. It is something like, suppose you want to find a very beautiful bride, just imagine. You go for a big crowd, there will be at least few beautiful women, right? In gases, there are so many molecules, so some of them will easily respond. In crystal, you are going to focus in a narrow region. You will lose a lot of energy by crystal. Crystal will break down. Crystal will do scattering. Because of all this one, Raman laser from the crystal or a solid state is very low. Possible, but we don't like it. We tried, but we said it's useless. Because in gas and liquid, I can get a good laser. Why I bother with the difficult stuff? 1 minute. Hello?